Hello again and welcome to my YouTube channel. This is the second part in the series about the new L12 version 5 which has just hit the market. As promised in the last video, my colleague in America, Ron, has spent a considerable amount of time, and I do say that because this board has been one of the most difficult to reverse engineer that we've done for some time. So many thanks to Ron. This is all his work. I'm purely, if you like, the messenger. He has done all the reverse engineering, and just to bring you up to date, I purchased the complete product, and in the last video I gave you the results of it showing instability. I was waiting for his to arrive because he purchased the kits, and I wanted to make sure it wasn't me doing something stupid, which I'm rather delighted to tell you is not the case, because he has built the kits. Well, he's built one of them so far, and he's built it exactly as per the supplied component. So he has basically the same product that I have, except mine was built by some slave labour in China, and Ron was built by his own slave labour in America. Other than that, the boards are identical. He's been testing them the same way with stabilised switch mode power supplies. So he has done basically exactly what I have done. And as you will see, I'm going to tell you now, but the results are very similar. Now, spoiler alert, at the time of making this video, we have still not got the board stable. To be honest, we may never get it stable, because I'm going to point out to you some of the flaws that we've found, as well as a basic circuit description. So if you do have that little bit of knowledge, you may be able to come and say, Mike, it's C4 or something like that, and I will be delighted to hear from you, because we're not the ultimate authority in this. We're just happy campers. Anyway, why do my videos always end up in silliness? I don't know. It's my personality or lack of it. As I started to say before the silliness crept in, at this stage we've spent between us probably about 50 or 60 hours on this already. The problem which we may have is that the board itself is just unstable because of its layout. The layout, to be perfectly frank with you, is quite poor. There are some very thin traces which really should be thicker because of the current capability, and the basic layout is really, I've got to choose my words carefully. I think atrocious is the word that comes to mind. Input leads going very close to output leads, and some actual faults in the board, which I'll show you presently. I think you'd be very foolish right now to buy these boards, either in kit form or in finished form, because the original or the last series L12 version 4 is basically not a bad board out of the box. There's a few little mods you can do to it, like the quiescent current adjustment. As things stand right now, don't buy this board. Hopefully in the next video we will be able to come back and say we found a mod or two which now turn it into a wonderful product. And don't misunderstand us. We both spent our own money on these boards, And at the moment, they are virtually landfill. Because why would you want an amplifier that is unstable? I mean, it's nonsense. And clearly these have not been tested properly. It sounds harsh, and I don't think I've ever been so critical about a board, but it's really because he is capable of doing good work. And the previous model, L12, we've been singing its praises for many years. We are both grossly disappointed that this has turned out like this. If you've bought them already and you do possess that little bit of skill and you can find the fault, get in contact with me and I will publish the results, test them of course ourselves, and give credit to you if you've been the one that solved the problem. But we haven't given up yet. So let's get on and have a look at the circuit. When you're viewing this, put the resolution of YouTube onto high 1080p, and then you will get the best definition possible. The first thing I should point out is that this is a completely DC coupled amplifier. If you're using it or testing it, there's any doubt that your signal source has any DC coming out of it, even if it's only a few millivolts, you will need to put a capacitor on the input. And I would suggest a bipolar, because you don't know whether the input coming in is positive or negative. For test purposes, I've used a 47 microfarad, simply because I've got some, and they are Nichicons. Put a capacitor on there if there's any doubt. The next thing I want to show you is, initially, it looks like there are no decoupling capacitors on the circuit, which is kind of true but equally not. If you look initially at Q9, which is this one, you will see it's basically a feed-through transistor, and it has the smoothing on the base of the transistor, and it does work perfectly well, but initially it looks like there are no bypass capacitors. It does have an effect on the stability of the amplifier, but at the moment that's still something we're looking at. But it does work from the point of view of smoothing the first part of the circuitry. So don't think at this stage it hasn't got any capacitors, because you do have C5 and C6, which provides smoothing for the latter part of the circuit. If you're looking at the output transistors, there is largely no extra smoothing on them. So I would suggest at this stage, that's not the problem with the instability, because my original test setup had cables in excess of a foot long, and it was suggested by one or two people that that was the problem. But on the recent tests, I've had the leads cut to the minimum length that I can physically use, and it made zero difference. So there's no point in also hanging small capacitors across these capacitors, because we've tried that and again it made zero difference. The second point, which amused both of us quite a bit, was the little FET marked on the board. Ron has spent quite a bit of time dissolving the little bit of gunk that's on top of that component. Why it's like that, I don't know, because it does nothing to enhance the circuit other than disguise what it is. But I can tell you now, it is not a FET, even though it's labelled as such on the board. Maybe it was originally going to be so, But why, I don't know, because it doesn't make sense to have a FET in that position, because they're basically two transistors in a current mirror. I mean, that's... The FET is actually not a FET, it is two NPN transistors. They're in the same package, and the package is put on the board inverted for some reason. The only thing possibly could be, as they're in the same package, they will track temperature wise, and so from that point of view it makes sense. Those two, or that little package of whatever it is, could be replaced by two standard NPN transistors, maybe glued together. It is what it is, and it seems to work with what it is, but what it ain't a FET. One or two, it really isn't. When we first started looking at the instability on this board, we thought we'd found the problem. If you look around this area here where it says almost connected trace on the board, the trace on the board, which actually goes from the speaker connection, if the wire hadn't been broken, it would have gone to the emitter of Q4, which would have produced a lovely oscillator. Clearly a mistake on the board. The thing that separates the output from that connection is a small hole on the board, which they've actually drilled through so that the plating isn't connected. It's so thin, it's micro, well, it's not even millimeters away. You've got that output connection almost going back to the emitter of that transistor, which is incredibly bad practice. It doesn't appear to be the problem with instability, because Ron has drilled out the hole completely, so there's zero chance of the platings touching. If you look at this part of the circuitry involving Q12 and Q13, they are mounted on the same heatsink and are thermally linked, so to speak, for that very reason. And it's part of the QS current adjustment, which those two, or one of those transistors in particular, runs very hot in my opinion, typically about 40 degrees Celsius. The quiescent current is a little bit unstable anyway. More of this on a later video, because I just really wanted to show you not what the answers are, because we haven't got them yet. Just before I finish the video, if anybody out there has done their own tests with test equipment, not with these in this case, and they have any theories about this and would like to put their 10 cents worth in, please contact me, and any work that you've done I shall acknowledge, of course. In the meantime, there will be a part 3 with a conclusion of some sort, sometime within the next couple of days or couple of weeks. Thank you for watching as usual.